Hello guys, this is Tutorial Space with Ola, and you are welcome to today's tutorial, which is the last in the set of series for our Radial engine project. It has been a long process getting up to this point, and we are really glad that we are finally here. Today's tutorial is supposed to be really short because we would simply be bringing in some parts, very few parts, and joining them all together. In the meanwhile, if you are yet to subscribe to this YouTube channel, I encourage you to do so, because other interesting projects which peradventure would not be this long would be done after this project is completed. Alright, I also want to use this period to appreciate those of us who have been following through with this project. I see you guys and I'm glad to know that a few people have enjoyed it so far. I know it has been really challenging, but that was the purpose from the very onset. Alright, so for today's tutorial, we complete this project by bringing in the remaining parts that we have for this engine assembly. Remember that if you have not subscribed to this channel yet, this is an opportunity for you to do so, and I hope that maybe kind of in a way that I have been able to convince you already that you should subscribe to this channel, and I hope that I've been able to earn your subscription. Alright, so we head straight into this. If you notice here that these parts are already vertically aligned, meanwhile I expect that in your own project that it's not yet vertically aligned. This is something that I definitely did not plan for, because I already created the end of the assembly, that is, I brought the remaining parts, and I expected that when I removed those parts that these would return to their previous position, but as we have it, they did not return, so they are this way, which was not the plan. However, you should not be bothered, because I don't think that should have any effect at all. It's just simply a change in alignment with what you probably have in your own project. Alright, so to quickly end up with all of this, the first thing that we will do is for me to bring in the parts to close up here, and that is going to be found under assembly files, and it is the cam housing sub assembly. So I bring this in, open, and place this here. We know automatically that our first constraint to apply is going to be the cylindrical constraint, so I apply that with this, and I select on this face here to apply the cylindrical constraint. Having applied the cylindrical constraint, I'll flip this over because the orientation is definitely wrong. Flip over. Please bear with me, my computer is getting slow, and that should be because we have a lot of parts here. When I apply this, alright, so it says assembly cannot be solved, the new relationship conflicts with existing assembly relationships. So I'm going to accept this. It says it would be unpredictable. So let's see. I've accepted that, but it's not showing any seek constraint here. So I'm just going to leave that way. And then the next thing for me to do is I'm going to try to align one of these holes here to the hole on the crankcase itself, which means to one of these holes. So I come over here and select on this, right, and I'll pick on this for now. Okay, zoom out. I expect that they are aligned. I click on alignment and apply. Alright, so that's good. And then the next thing for me to do is going to be to close up these parts here. So I would rotate to see this face, select, and join that together with this face here. All right. Bear with me because I know that these are already aligned, like I previously said, and this is because I already did this, and it's kind of just was not possible for me to return it back to the previous position. All right, but then even though it's this way already, the only thing that we need to do is actually to apply the cylindrical constraints between this ram bearing and the pound here. So in your own case, just try your best to find the cylindrical constraint between the pound and the ram bearing that is located on the cam housing. When I do that, I apply, and what you should notice in your own project is going to be that the relationship that you apply to this is going to be replicated on all of those corresponding rods all around the engine. And the reason is simple. In the process of creating these parts and placing all of these cylinders here, if you remember that we did just one cylinder sub-assembly and then we patterned it all around. So in the process of creating that pattern, we also chose to pattern the relationships. That was done to save time, because if we hadn't done that, then what we would have had to do would be to bring in the rods one by one after patterning all of the cylinders themselves, and then we'll have to bring in the rods one by one and to be placing everywhere. All right, but then something also important to note is that before you place your constraint here, because I think there's a possibility that you might be having an issue with that. I'm still sorry, like I said, but what you would need to do is, in case the constraints do not work, simple. All you need to do is look for the component pattern here in the feature manager, and then you search for the first element, you right click on it and select on adaptive. All right, yeah, I think we can also just, okay, so it cannot be made flexible simply because we pattern them all around. No problem, but make sure that your adaptive is selected before you apply your cylindrical constraints. So we do the same thing for the second push rod, and it's not called a push rod. We do the same thing for the second, okay, it's called a push rod. For second push rod, and then this ram bearing. So cylindrical constraint for that, and cylindrical constraint for the parts within. And cancel. So if you have done that and you created or selected on adaptive for this part, and it's going to do, you're going to have something that looks just like this. All right, that was not the ideal way to do this, simply because we try to cut out time by patterning around, but in the process of having to create an animation, what you'd have to do is to bring in these rods one by one. But this project has already been so long, so there was absolutely no need for me to elongate it any further. All right, so the next thing for us to do is, now that we have this done, we would have to bring in our bolted connections to fasten this cam housing to the crank. So I go over to place and place from content center, and then we go over to socket head. Okay, and then I look for a DINEN. Okay. DINEN ISO 4762. Yeah, correct. DINEN ISO 4762. I apply this, and then with the bolt in hand, I would rotate to look for the hole inside the crankcase. So I know that I have the hole here, but we want this bolt to go all the way into the crankcase. So the hole I would search for would be the hole within the crankcase. It's going to be, I think, a little bit tricky, but I will just rotate. Remember, due to my own type of view set, my threads or holes are depicted with the white. So you might just be seeing just the thread if you are using the proper or normal view. So I'll select on the thread here, right? And then select on this face out here to place this connection. So we have something like this. Okay, and I would say insert multiple. All right. The bolt should be definitely longer than this, so I don't know why it is showing this way, but we can see from guidance that the hole in the crankcase is as deep from here to this point. So what I'll just do is just to drag this, let's see, somewhere here to see how the bolt adjusts. Alright, so it's got up to that point. Maybe I'll bring it backward a little bit. I'm not very sure if this is the ideal way to do this, but it is what it is. So I'll drag this back just a little bit, Okay, I think this is just what I'm gonna do. And I select on apply. Alright, now, so with all of our bolts connected and locked, I would select on the escape button, and then what we would be doing is to bring in the rest of the parts which are available under our file folder, rotary engine, and then I'll look for something called the cone. This is how it looks. It's a very unique component. I would bring this in. Okay, I think I will just bring them all in once and for all. So I bring back all these parts. Let me see. I bring in this called the Minima. I have no idea why that's the name. I think it's German, but I'm not sure. I bring in also the nose, these parts, and I think the last part to bring in should be the propeller, but let me just check through to be certain. All right, yeah, so that's all. Open and drop. Okay, escape, and then what we will do first of all is to place our cone here. So I'll apply the very common constraint that we have become accustomed to with this project, which is the cylindrical constraint. So between this, between this and this. All right, so let's see the orientation. So it's looking or facing this way, but that's not what we desire. So I'll flip this over and apply this. Yeah, just accept this relationship. All right, so with that, I would place a constraint between this face here and the rear part of our cone here. Okay, so that's that, and I would say apply. All right, and let's see. So I'll cancel this. I go over to this should be our cylinder sub assembly. No, piston sub assembly. Yeah, so I'll go over to piston sub assembly and make the mid plane visible for us to see, and that should be the ZY plane. I'm taking my cue from here. I would make the ZY plane visible. I'll right click and select on visibility. Then I scroll over to the just brought in cone to make the same plane visible. Let's see. we have to be certain. I'll drag this away. Okay, scroll in. Alright, so the YZ plane also, I make this visible. Then I apply my constraint between the both of them, and the reason is simple, so that the idea is that when the shaft rotates, that this cone also rotates with it. So I would place a constraint between this plane and this plane. So I'll make that flush and apply. Just accept. Alright, so with all that, I can cancel this and make the planes invisible. Don't mind me, I think you might be able to hear my mouse scrolling. Alright, so we have this, and then the next thing we will do is to bring in the Minima and place here. So I go over to constraint and apply the cylindrical constraint again between this shaft and the Minima here. Alright, so if you notice that in the Minima it seems like we have something like a cone shape here. So this has a larger diameter, this has a smaller diameter, and this simply depicts that this fits into this. So what we'll do is I'll flip this over, and having flipped this over, I would apply, accept the relationship, and then I would mate also this face here of the bearing to the rear part of this Minima. I'll scroll this way and apply to this. Alright, so I'll apply. Alright, then our next part would be to bring in our propeller. So the propeller is here, and if you notice, if I scroll this way, we have something like a groove here, right? I don't think it fits in perfectly into this point due to the fact that maybe the drawings used were not accurate, but that could easily be changed. Let's see, if I measure this, let's see, choose measure from this face to this face, this is 1.5, okay, and this is 20 millimeters in diameter. Alright, if I check through with this also, measure, expect it to be 1.5, okay, and this is probably not 20, yeah, so this is 16. It can be adjusted, and simple, I'll right click on this part, say edit. Alright, we are in this part, workspace. I'll go to direct, size, so I select on this outer diameter, I come over here, change the diameter from 16 to 20. Alright, 20, and I check this. So that was really simple. I cancel, return. The truth is that these things are part of design. Dimensions are always something that we have to look out for. So there is a high probability that in creating something as large as this, that some dimensions would be conflicting. It happens. So I go back to assembly and place our constraint. So this is going to be between this, and we place with this. Alright, let's see. Okay, so this is good. And then I place the constraint between this face here. I rotate and this face. All right, so with that, apply. Perfect. And our last constraint is going to be this cylindrical constraint together with the cylindrical constraint of our nose. All right, where is it? Okay, so it's here. Definitely this is the wrong direction, so I flip this over and apply. At this point in time, I'm glad to tell you that we have just one more constraint to apply. I place a constraint between this face. Let's rotate this and place with this face here. Oh, voila. All right, and I apply. Cancel. All right, guys, this is pretty good. I would say impressive. And I'll say the only downside to this is that it was really long. And okay, that's not the only downside. Another downside is that we had to do a lot of what's it called, modifications to this project, and I mean to many of the parts. It's possible that we could have eliminated that process by using what, as I said before the assembly procedures began, using the process or procedure called the skeletal modeling approach. But since we already had the parts and trying to create everything together, bringing in all the parts, it complicates the whole process. So I thought, it's kind of better to create the parts separately and bring them all together. Hence the reason why we had some misfits and then we had to do some modifications. Alright guys, I think there's one more thing to change or to apply, and it's going to be the constraint between these. I'll right click on visibility for this. I'll do the same for the nose, the same plane, this visibility, and lastly I would go over, or I could just use the cone because the cone is already aligned to the crank sub assembly or the plane. So what I'll do is I'll just place constraints. Ideally I place constraints between these planes so that ideally when one rotates, the other part rotates with it. Apply. And lastly, I'll place, let's say, between this plane and where is the plane for the cone. So I think I can just select it here. Alright, so apply also. And that's good. So now we are really done. No more constraints to apply. So guys, I hope you guys have enjoyed this tutorial so far. I hope I have not bored you all through the process. My plan is that after this I will try to create a rendered image of these parts, of this assembly, and then as time progresses I would see if I would be able to set apart time to actually create an animation for all of this. But in the meantime, this is where we are going to be stopping with this tutorial, and I seriously hope that you have enjoyed it. If you indeed have, do not forget to give it a thumbs up and to share the project. Just share it to your friends. And at this point, if you are still not yet convinced to subscribe to this channel, I would like you to consider it, because as I said, I'm really looking forward to doing even far more interesting projects than this. They definitely will not be this long and they won't be as complicated with so many parts, but then there are also projects that would be of great interest to most of us. Alright guys, and the ladies who have also been watching, I appreciate you all for all of this. I'll go ahead to save my parts, and yeah, let's see. I suppose I would also like to see how it looks on the when there is a shadow involved with it. Alright, looks pretty nice. So guys, thank you for sticking through to the end. I would see you guys in the next tutorial. Hopefully it comes very soon. But I'll see you guys later on. Thank you very much. And remember, keep watching this space.